Yeah, the topic is height versus node analysis for AVL trees. Similar analysis we have already done for general binary trees and strict binary trees, and also for complete or strict n-ary trees. We have done same analysis. Now we'll do that analysis upon AVL tree. So what we have to do is, if height of a AVL tree is given, height is given, then find minimum how many nodes are possible in that height, maximum how many nodes possible in that height. So AVL tree is a binary tree only, basically. Binary tree, then binary search tree, then it is height balanced binary search tree. So basically it is binary tree. So in any binary tree, if height of a tree is given, then maximum how many nodes can be there? 2 power h plus 1 minus 1 nodes will be there. Yes, we know this one. So I don't have to explain that one. So this is coming from binary trees, right? So anyway, I will come across this formula once again. Now the question is minimum how many nodes if height is given. So how to get the formula? See, formula by taking the sample values or examples from the observation, you can prepare the formula. So formulas comes from observation. Let us take some examples of some heights of AVL trees, then see how many minimum nodes required, then we'll come up with the formula. So let me show you some examples. First example, let us assume that height is 1. What about height 0? We will start height from 1 onwards, right? So here we will start from 1. So if height is 1, then just one node. I'm not labeling, I'm not putting any values. So how many nodes required? Minimum 1 only. Maximum also 1, minimum also 1. Height is not 0, height is starting from 1. The next, if height is 2, then minimum how many nodes required? 2 nodes. Yes, height is 2 nodes. If height is 3, then the minimum how many nodes? 3 nodes. 3 nodes required. Minimum 3 nodes. No, wrong. This is wrong. Is it a AVL tree? AVL tree means height balance. So if you check the balance factors, this is 0, this is 1 and this is 2. This is not balance. So I need one more node on this side to make it balance. Yes, now the balance factors are 0, 0, 1, 0 and this is 1. Yes, this is balance. That's it. Minimum node means it must be balanced. So minimum how many nodes required? 4 nodes required. So take 4. Then if the height is 4, then minimum how many nodes required? 1, 2, 3, 4. Is it balanced? No. This side I need some nodes. One node, is it sufficient? No, still it is imbalance. One more node, is it balanced now? Yes, that is balanced. What about this node? This is not balanced. Now everything is balanced. Let us check 0, 1, 0 and this is 1, this is 0, this is minus 1 and this is 1. 1, 2, 3, 1, 2. Yes. So total how many nodes required? 1, 2, 3, 4, 5, 6, 7. 7 nodes required. Minimum 7 nodes required for height 4, where the heights are starting from 1 onwards. Then for 5 also I will draw it here. There is no space on that side. If height is 5, then minimum how many nodes required? I will draw it. 1, 2, 3, 4, 5. No, this is not balanced. If you have 5 nodes this side including this one, 4 nodes must be there, then only it is balanced. Okay, 1, 2, 3. Total 1, 2, 3, 4. Yes, perfect. Including that root. Then what about this? For this, including this one, 1, 2, 3, 4 you have. So you should have 1, 1, 2, 3. Now it is balanced. Now here you have 3. So here you should have 2. Balance. Here you have 3. Here you should have 2. Balance. Now this is balance. If you check the balance factors for all the nodes, then the tree is balanced. Total how many nodes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So minimum 12 nodes are required. Yes. Now we have enough examples for observation and to get the formula. Now I have some set of values. Let me prepare a table. If height is given, then how many nodes for a given height? Let us make it as a function. So if height is 1, 1 node, 2, 2, 3, 4, 2, 2, 3, 4, 4, 7, 4, 7, 5, 12, 5, 12. I'll extend it. 6 and 7. Tell me the answer for these. How I got this 12? Let us observe. 4 plus 7, 11. 11 plus 1. Okay. 4 plus 7 plus 1. Am I getting this value also like that only? 2 plus 4, 6 plus 1. Yes, 7. How I got this one? 1 plus 2, 3 plus 1, 4. So it means this one is 7 plus 12, 19 plus 1, 20. Then how to get this one? 12 plus 20, 32 plus 1, 33. Yes. So the formula is number of nodes for a given height is previous two values are added and plus 1. So n of h minus 2 plus n of h minus 1 plus 1 plus 1. Yes, this is the formula. Then for the very first value, I should have two values with me. So when height is 0, answer is 0. When height is 1, then the answer is 1, right? Otherwise, this is the answer. So when height is 0, answer is 0, height is 1, answer is 1. Otherwise, this is the formula used. So formula for minimum is this one. And for this is the table. So minimum nodes can be obtained by this formula. So I should write down this formula here for minimum nodes. So I will not write the formula. I will say look in the table. So for minimum nodes, look into the table. So if height is 5, minimum 12 nodes, height is 6, minimum 20 nodes, like this. Then there is one change here. See, I started height from 1 onwards. When I have only one node, height is 1 onwards. So if height is 3, then 7 nodes. These are 7 nodes, right? This height is 3, 1, 2, 3. So maximum 7 nodes when the height is 3. So this maximum nodes formula, we will get 2 power h plus 1 minus 1, but now we will have just 2 power h minus 1 formula because the height is starting from 1 onwards. So maximum nodes formula is this one. So if I add these 1 node and these are 2 nodes and these are 1, 2, 3, 4 nodes, so 2 square. So this is 1 plus 2 square is equals to 2 cube minus 1. 2 cube minus 1 is what? 8 minus 1, that is 7. So yes, we have 7 nodes. So this is 2 cube, height is 3. So just 2 power h minus 1. Now we have the formulas. If height is given, then minimum nodes and maximum nodes. We need another formula. If nodes are given, then what is minimum height and maximum height? So let me write down, I'll remove this. If n nodes are given, then find minimum height and maximum height. So if you remember in binary trees, what we did is, we converted this minimum formula to maximum formula and maximum formula to minimum formula. We'll do the same thing here. So we don't have to do any analysis. See, maximum nodes are n equal to 2 power h plus 1 minus 1. Then minimum height will be h is equals to n plus 1 log base 2. So log base 2 n plus 1. No need of minus 1 because in power we don't have plus 1 here. So log base 2 n plus 1. Then what about maximum height? This comes from minimum nodes formula. There it is, look on the table. So here also look in the table. You have to look into the table. How? Let me give an example. If I have 12 nodes, then what is the maximum height? 5. If I have 13 nodes, 13 is less than 20. So this side only, here only. 13 nodes also 5. 15 nodes, 5 only. Maximum height, 5. 19 nodes, height is 5 maximum. See, these are minimum nodes required for getting this height. Now I have 20 nodes. Okay, maximum height is 6. Maximum height is 6. So from this 12 to 19, maximum height is 5. And 20 to 32, maximum height is 6. So you can look into the table and you can read it this way. Instead of from height towards node, you have to see from node towards height. That's it. So you can find out. So you have to practice this little bit, put it by yourself on using pen and paper, then you will remember everything, right? Just practice it once, you will remember it. So we have done in-depth analysis of AVL tree. Now one last thing. See this formula for minimum number of nodes formula, right? This one, minimum number of nodes formula. Actually, this formula is meant for this one and also useful here. Height is given, nodes, minimum nodes formula. This formula is same as Fibonacci series formula. Yes, Fibonacci series is famous for being a balanced series. Balanced series. You take any two terms of Fibonacci series like fi and fi plus 1, any two terms. For example, f10 and f11, two terms. Then f11 by f10 if you do, or fi plus 1 by fi if you do, ratio will be 1.6 approximately, not exactly. It may be 1.59, it may be 1.57 also. You should accept it as 1.6, or it may be 1.6162 also. Approximately 1.6. So any two consecutive numbers, if you take the ratio, it is 1.6. So Fibonacci series is believed to be a balanced series. So this formula is matching with Fibonacci series, means AVL trees are also balanced. This is a proof that they are balanced, because so their formula for node versus height is same as Fibonacci series. Then one last thing. Minimum height is log n plus 1 base 2. Maximum height, look into the table. Table is from the formula. So from this formula, can't I calculate height? Yes, approximately if you calculate from this one, there is a derivation. If we derive that and get the answer, then approximately it is equal to 1.44 log base 2 n plus 2. If you use this formula and convert it in terms of log n, we get this answer. So minimum height is also logarithmic, maximum height is also multiple of logarithmic, but logarithmic only. So AVL tree's height is always in terms of log. That's it. This is enough with the analysis of height versus nodes.